So solve the simultaneous equation log x plus log y equals 1, and then x plus y equals 11. So this log x plus log y can be written as a single equation, which becomes log xy equals 1. But we are working in base 10, and therefore xy is equal to 10 exponent 1. Xy is equal to 10. So this becomes our equation 1. Then x plus y equals 11 becomes our equation 2. So let's then make x the subject in equation 2 and put it in equation 1. So x is equal to 11 minus y. That is equation 3. Then let's then insert equation 3 in equation 1. So this becomes 11 minus y, which is the x portion, times y equals 10. So let's expand. We then have 11y minus y squared equals 10. So let's bring everything to the right hand side of the equation. So we have y squared minus 11y plus 10 is equal to 0. So now you are supposed to find two numbers that when you multiply, you get positive 10, but when you add, you get negative 11. And we see that those two numbers are minus 1 and then minus 10. Minus 1 times minus 10 is positive 10. However, minus 1 plus minus 10 is minus 11. So we have y squared minus y minus 10y plus 10 is equal to 0. Yes, 10. So we can factorize y out. So we have y minus 1, then minus 10, y minus 1 equals 0. So in one bracket, we have y minus 10, and in another bracket, we have y minus 1 equals 0. So y is equal to 1 or 10. But we know that from equation 3, we know that x is equal to 11 minus y. So if y is equal to 1, then x is equal to 11 minus 1, which is equal to 10. Then if y is equal to 10, x is equal to 11 minus 10, which is equal to 1. So given that 3 log m base 2 is equal to n, and log 4 m base 2 is equal to n plus 4, find the values of m and n. So we know that n is equal to 3 log m base 2, and then log 4m base 2 is equal to n plus 4. So let's put the value of n. So it becomes log 4m base 2 equals 3 log m base 2 plus 4. So let's take this to the other side of the equation. It becomes log 4m minus 3 log m base 2 is equal to 4. So this can also be written as log 4m, this base 2 minus log m, then we bring the 3 on top, exponent 3 base 2 equals 4. So we can then write this as a single log, and since it is subtracting, it becomes log 4m divided by m exponent 3, this is base 2, is equal to 4. So 4m divided by m exponent 3 is equal to 2 exponent 4. So we can see that one of the m's can cancel this one on top. So we have 4 divided by m exponent 2 is equal to 2 exponent 4 is 16. So we can make m squared the subject. So m squared is equal to 4 divided by 16. So we're having m squared equals 4 over 16. So we take square root of both sides. And so m is equal to plus or minus square root of 4 over 16 becomes plus or minus 1 over 2. So we have the values of m. All we need to do is to find the values of m. I remember that we're given n equals 3 log m base 2. So n is equal to 3 log. Then m is 1 over 2. So this becomes 1 over 2 base 2. And this is n is equal to 3 times log 1 over 2 is the same as 2 exponent minus 1 base 2. So n is equal to, let's bring minus 1 down. So it becomes 3 times minus 1 log 2 base 2. So n is equal to log 2 base 2 is 1. 3 times minus 1 times 1. And therefore n is equal to minus 3. But we can put the value of m equals minus 1 over 2 in this equation, because the log of negative numbers will make n undefined, and therefore m equals 1 over 2 and n equals minus 3. Solve the simultaneous equation log into bracket x minus 2 plus log 2 is equal to 2 log y, and also log into bracket x minus 3y plus 3 equals 0. So let's start with the first. So let's write this as a single log. This becomes log x minus 2 times 2 equals, then I'm bringing these 2 on top, becomes log y exponent 2. So now this becomes log 2 times x is 2x. 2 times minus 2 is minus 4 equals log y exponent 2. But remember what we said earlier. We said that if log b base a is equal to log c base a, it implies that b is equal to c. And therefore, since they have the same basis, which is base 10, and we can equate y squared equals 2x minus 4. So this becomes our equation 1. Then let's come to this side. So this side too will become x minus 3y plus 3 is equal to, this is in base 10, so 10 exponent 0. And therefore, x minus 3y plus 3 is equal to 10 exponent 0 is 1. So x minus 3y plus 3 minus 1 is equal to 0. And therefore, x minus 3y is equal to minus 2. So this becomes our equation 2. So let me write the equation 1 down. The equation 1 is y squared is equal to 2x minus 4. So this is equation 1. Equation 1. So from equation 2, we can see that x is equal to 3y minus 2. So this is equation 3. So let's put the value of x in this equation. So y squared becomes 2 times 3y minus 2 minus 4. So y squared is equal to 2 times 3 is 6y. 2 times 3y is 6y. Minus 2 times 2 is 4. Then minus 4. So y squared Then I'm bringing everything to the other side. Minus 6y. Minus 4 becomes minus 8. If we take it across the equal sign, it becomes plus 8 equals 0. So we must look for two numbers that when you multiply, you get positive 8. But when you add, you get minus 6. Those numbers are minus 4 and minus 2. And therefore, we have in one bracket y minus 4 times y minus 2 equals 0. So y is equal to 2 or y is equal to 4. So the values of y are y equals 2 or y equals 4. But remember that we've said that x is equal to 3y minus 2. So if y is equal to 2, then x is equal to 3 times 2 minus 2. And that is equal to 4. And if y is equal to 4, x is equal to 3 times 4 minus 2. And that is equal to 12. 3 times 4 is 12 minus 2. This is equal to 10. So as x is equal to 4, y is equal to 2. And as x is equal to 10, y is equal to 4. So find without using tables or calculators the value of log 27 base 3 minus log 64 base 1 over 4 divided by log 1 over 81 base 3. So this is equal to log 27 is the same as log 3 exponent 3 base 3 minus log 64 is the same as log 4 exponent 3 base 1 over 4 divided by log 81 is the same as log 1 over 81 is the same as log 4 exponent minus 3 base 3. Sorry, it is rather log 3 exponent minus 4 base 3. So this is equal to, I'm bringing this down, so it becomes 3 log 3 base 3 minus, now log, I want to change this to, this is the same as 4 divided by, let me do something here, 4 divided by 1 exponent 3 is equal to, when I flip this fraction, I can change the sign of the exponent. So this becomes 1 over 4. Then I will change this to be minus 3. So that's what I'm going to do here. I will do here as 1 over 4 exponent minus 3 divided by, then I'm pushing the minus 4 down. That becomes minus 4 log 3 log 3 base 3. So let me continue from here. This is equal to log a base a is equal to 1. So this is equal to 3 times log 3 base 3 is 3 times 1. Then, but remember here is base 1 over 4. So minus log, I'm pushing the minus 3 down. Minus 3 log 1 over 4 base 1 over 4. And divided by, becomes minus 4 log 3 base 3. So this is equal to 3 times 1 minus 3, because log 1 over 4 times base 1 over 4 is 1, divided by minus 4. So this is equal to 3 times 1 is 3, minus 3 becomes plus 3, which becomes 6. 3 plus 3 is 6, divided by minus 4. So this is equal to 6 divided by minus 4. And this is equal to minus 6 over 4. And that is equal to minus 3 over 2. Log, in brackets, log n base 2 all squared plus log n cubed base 2 is equal to 10. Now, let's notice this. Log n base 2 all squared is not the same as 2 log n base 2. It is not the same. However, log n exponent 3 base 2 is the same as 3 log n base 2. So let's notice the difference. So what we will do here is, this is the same as log n base 2 all squared plus, I'm bringing the 3 down, 3 log n base 2 equals 10. So let a to be equal to log n base 2. So this then becomes, wherever we see log n base 2, we'll put a. So log n base 2 is here, so we'll put a inside. So it becomes a squared plus 3a is equal to 10. So I'm bringing the 10 to the side of the equation. So it becomes a squared plus 3a minus 10 is equal to 0. So you must look for two numbers that when you multiply, you get minus 10. But when you add, you get plus 3. So you see that those numbers are plus 5 minus 2. So this is a squared plus 5a minus 2a minus 10 is equal to 0. So let's factorize a out. We are left with a plus 5. And we factorize minus 2 out. We are left with a plus 5 here equals 0. So the values in one bracket we have, let me write it here. In one bracket we are having a minus 2 times the other bracket is a plus 5 is equal to 0. So the values of a are a equals minus 5 or 2. So the values of a is equal to 2 or a is equal to minus 5. But remember we said log n base 2 is equal to a. So when a is equal to 2, then log n base 2 is equal to 2. So n is equal to 2 exponent 2, and therefore n is equal to 4. Then when a is equal to minus 5, log n base 2 is equal to minus 5. N is equal to 2 exponent minus 5. N is equal to 1 over 32. If f of y is equal to log into bracket y plus 1 base 2 minus log into bracket y plus 3 base 2, find the domain of f of y, and then b, solve f of y equals 1. Okay, so let's start with the a part. So we have f of y equals log y plus 1 base 2 minus log y plus 3 base 2. So let's write this as a single log. So f of y is equal to log y plus 1 divided by y plus 3 base 2. So now, in finding the domain, what we must ensure is that the numerator must be greater than 0. The reason is because the log of negative numbers 0 and x less than or equal to 0 makes this f of y undefined, and therefore y plus 1 should be greater than 0. Means that y should be greater than minus 1. So the domain of f of y is such that y is a real number, but y should be greater than minus 1. Then now let's come to the b part, which is f of y equals 1. So what we must do is that we must equate all of this equation f of y to 1. But we've already written f of y as log y plus 1 over y plus 3 base 2. So all of this must be equal to 1. So y plus 1 divided by y plus 3 should be equal to 2 exponent 1. So let's cross multiply, or let's multiply through by y plus 3. So this becomes y plus 1 equals 2 times y plus 3. So let's expand the bracket. Y plus 1 is equal to 2 times y is 2y, plus 2 times 3 is 6. So we can take 6 to this side and bring y to this side. So we get 2y minus y equals 1 minus 6. So y is equal to minus 5. If 1 over 2 plus log x squared plus x minus 5 base 4 is equal to log x squared plus x plus 10 base 4, then find the values of x. So what we need to do is we'll bring this log to the left hand side and take half to the right hand side. So this becomes log x squared plus x minus 5 base 4 minus log x squared plus x plus 10 base 4 is equal to minus 1 over 2. So we can then write this as a single log. And since it is minus, then we will divide this by this. So it becomes log x squared plus x minus 5 divided by x squared plus x plus 10 base 4 equals minus 1 over 2. Minus 1 over 2. So x squared plus x minus 5 divided by x squared plus x plus 10 is equal to 4 exponent minus 1 over 2. So this is x squared plus x minus 5 divided by x squared plus x plus 10 is equal to 4 exponent minus 1 over 2 is the same as 1 over 2. So our equation was x squared plus x minus 5 divided by x squared plus x plus 10 equals 1 over 2. So what we do here is we cross multiply. So we will then have 2 times x squared plus x minus 5 equals 1 times x squared plus x plus 10. So 2 times x squared is 2x squared. 2 times x is plus 2x. 2 times minus 5 is minus 10 equals 1 times x squared is x squared plus 1 times x is x plus 1 times 10. So let's bring all of this to the other side of the equation. We will get 2x squared minus x squared plus 2x minus x minus 10. Then this becomes minus 10 equals 0. So 2x squared minus x squared will give us x squared. Then plus 2x minus x will give us plus x. Minus 10 minus 10, it becomes minus 20 equals 0. So we look for two numbers, and when you multiply, you get minus 20. And when you add, you get plus 1. So you see that 5 times minus 4 is minus 20. But 5 minus 4 is 1. So we get in one bracket x plus 5. And in another bracket x minus 4 equals 0. So x is equal to minus 5 or x is equal to 4. Solve A. 3 exponent y equals 12. And then using the results in A, find the value of log 4 base 3. So we have 3 exponent y equals 12. So what we can do is we can find log 3 exponent y equals log 12. So this becomes y log 3 equals log 12 is the same as 4 times 3. So 4 times 3. So we then have y log 3 is equal to log 4 plus log 3. So let's divide through by log 3. We get y is equal to log 4 divided by log 3 plus log 3 divided by log 3. So you see that this can cancel out, so that we'll get 1. So at the end of the day, we get y equals log 4 divided by log 3 plus 1. And then log 4 divided by log 3 is 1.2619 plus 1. And therefore y is equal to 2.2619. Then the question is saying that we should use the result in A to find log 4 base 3. But you see that y is equal to log 4 over log 3 plus 1. Remember what we said. Log 4 base 3 is the same as log 4 divided by log 3. So therefore, log 4 base 3 is equal to log 4 divided by log 3. So let's make log 4 divided by log 3 the subject here. So log 4 divided by log 3 is equal to, we take 1 to the other side, y minus 1. And we already know the value of y. So this is equal to, the value of y is 2.2619 minus 1. And this is equal to 1.2619. The data below fits the equation of the form y equals bx exponent m. And these are the x and y values. So draw a suitable table and use it to find the value of b and m. And hence find y if x equals 6. Y is equal to bx exponent m. What is log y? Log y is equal to log bx exponent m. So log y is equal to log b plus log x exponent m. So log y is equal to x exponent m is m log x plus log b. What does this mean? Remember the equation of a straight line is y equals mx plus c. So log y, if in this case is log y, equals m then x, which is log x, plus the c, which is the y-intercept. Sorry, the b didn't come, so becomes plus log b. So the log y becomes log y. M is the gradient, which is the coefficient of x. But in this case, x is log x. Then plus c, the y-intercept. The y-intercept is log b. So what we need to do is to then change this table into log y and then log x. So if we do log y, log x, then we will plot the values of log y against log x, and we can find the gradient and then the y-intercept. So let's go ahead and do that. So you see that we have two tables. Remember that our equation is log y is equal to m log x plus log b. So this is our table of x and y. So when you take one, you find log 1 and you put it in the table of x. You take 2, log 2, log 3, log 4, then log 5. And you then take the y values too, and then you find their logs. So at the end of the day, we are going to plot a graph of log y against log x so that we can find the values of m and then b. So let's go ahead and plot the graph. Now we can see from the table of log y and log x values that there are no negative numbers, and therefore we are only going to be dealing in the positive values, and that is why our graph is like this. So the lowest x log x value is 0, and then the highest is 0.69. So if we take a scale of 1 is to 0.1, 1 unit is to 0.1, and we should be able to plot all of this on the x-axis. So 1, 2, 3, 4, 5, 6, 7, 8. The x-axis has 10 units, but for convenience sake, we are doing it at 8. So this will be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and 0.8. Then on the y-axis, we see that the lowest y log y value is 0.3010, and the highest is 1.708. So if we take a scale of 1 unit is to 0.3, then we will be able to get all the y values as well. So here will be 0.3, then here's 0.6, then this place is 0.9, and here's 1.2, and here's 1.4, and here's 1.6, and this aspect is 1.9. Sorry, I've made a mistake. So 1.2 plus 0.3 is 1.5. Then 1.5 plus 0.3 will give us 1.8. And 1.8 plus 0.3, here will be 2.1. So let's correct that mistake. So the first point is 0 on the x-axis and 0.301 on the y-axis. So it's a little bit above 0.3, so somewhere here. Then the next one is 0.301 on the x-axis and 0.903 on the y-axis. So 0.3 and 0.9. It's somewhere here. And then the next value is 0.477 against 1.255. So 0.477. Now remember that each unit becomes 0.01. So 0.477 is around 0.48, which is somewhere here. And then that will correspond to 1.255. This is 1.2. So 1.255 should be greater than 1.2. So that will be somewhere here. It's a little bit, no, it's somewhere here. And then the next digit is 0.6. So 0.6. And we are plotting it against 1.5. So 0.6 against 1.505. So a little bit above 1.505. So it's going to be somewhere here. And then the next one is 0.69. So it's almost 0.7 as against 1.7. Or 1.7 is greater than 1.6. So it's somewhere here. So it's going to, so 1.7, a little bit below 1.8. So it's going to give us a certain value somewhere here. So if we join our plot, so the next thing is we are supposed to find a gradient of this curve. So for the gradient, what we will do is that we need to find 2 points. So let's assume that we have found some 2 points here, and then connect them, and then use that as our reference frame to find the gradient. So now we know that m is equal to y2 minus y1 divided by x2 minus x1. So m is equal to, if you trace this on the y-axis, we'll trace it somewhere here. And that's going to give us, if we trace it well, we are going to get a value somewhere around 1.5. Then minus, then this is somewhere 0.6 divided by, and the denominator is somewhere 0.6 minus 0.15. And when you do it, you see that m is equal to 2. So this is equal to 2. Then now let's find the value of b. You can find the value of b. We know that log b is equal to the intercept, the y-intercept, which is 0.3. So b is equal to 10 exponent 0.3, and therefore b is equal to 1.995. So remember that the equation that we're given is y is equal to bx exponent m. So y therefore is equal to b, which is 1.995, x exponent m, and our m is 2. Then he says that we should find the value of y if x is equal to 6. So all we just need to do is to put the value x equals 6 in this equation. So therefore y is equal to 1.995 times 6 exponent 2. And if we do that, the value of y is equal to 71.82. And that is approximately 72.